Hi, thank you for joining us for this special edition of IT Showcase. Today we're going to learn a little bit about how Microsoft IT is using Azure's Platform as a Service capabilities to deliver real-time IT, software as a service functionality for partner-focused organizations across Microsoft Enterprise by architecting and migrating a business-critical application, namely the Partner Velocity Platform, or PVP, using a hybrid cloud strategy. My name is Abel Cruz, and I'm a Principal Program Manager lead in the Sales and Marketing organization within Microsoft IT. I'm responsible for driving the long-term technology strategy for the Partner Velocity Platform, which is the engine behind the Microsoft Partner Network, also known as NPN. With me today, I have Cleve Littlefield. Cleve, why don't you introduce yourself to our audience and tell us a little bit about your background and your responsibility within MSIT.
Thanks, Abel. As you said, my name is Cleve Littlefield. I'm a principal architect in that Partner IT division, and I'm also responsible for the technology strategy of the Partner Velocity Platform.
Great. So today we're going to talk a little bit about some of the lessons learned of moving PVP to Windows Azure. But before I do so, I want to share with our audience a little bit about what is PVP and its role in MSIT. So PVP, as I mentioned earlier, is the Partner Velocity Platform, which is the engine behind the Microsoft Partner Network. I think it's very well known, both inside of Microsoft as well as outside of Microsoft, that roughly 95% of the revenue that Microsoft generates comes from our partners. As such, as you can imagine, such a platform that drives the engine, or is the engine behind our platform experience, our partners' experience with Microsoft, is very critical, not only for Microsoft, but also for our partners. So NPN is the portal that Microsoft.com uses, and is the main portal for Microsoft to come in and learn about opportunities to strengthen their technical capabilities and gain experiences to help serve their own customers better and be part of a community that also sparks innovation and connection. And of course, then the platform, the PVP platform, is that engine behind that. So now with that context in mind, Cleve, can you tell us a little bit about the business landscape that sort of trigger the re-architecture and migration of PVP from on-premises to Windows Azure?
Sure, Abel. So the Partner Velocity Platform, the main thing we as Microsoft want to make sure that our partners are well suited to serve customers. And as that, we have about 640,000 active partner organizations in the PVP platform. Those partners try to participate in many programs, about 40 different programs that we have running, from competencies to sub-programs like our Microsoft Action Pack subscription. And like I said, there's about 40 of those. Each of those programs have about 6 requirements per program, so to make sure that they're well positioned to meet partner needs. Each of those programs also have individuals that are associated to the companies, such as Microsoft Certified Professionals, that again help them meet those requirements. And they have other assets like references, customer satisfaction data, things like that that we have to keep track of. There's about 25 million of that. All these, I give all these numbers to show that we have a multiplicity effect. All those individuals times all those assets times all those programs times all those organizations really leads to the need to have a dramatic scale. In addition to that, our business wants to move faster. Every year Microsoft is coming out with new software, and we have new programs that marketing needs to reach. And our current architecture really doesn't allow for that.
No, but it seems to me, Cleve, that the architecture today and the solution is actually working, and it's providing business value to our constituents inside of Microsoft. So then the question that I have is, why didn't we just take that solution that we have today and simply move it over to Windows Azure? Why do we have to re-architect it and go through all these extra hoops?
That's a good point, Abel. And I think the main reason comes is that right now our engine is a scale-up architecture entirely located in the database. And because of that, we have a bottleneck in the database. And so if you move that over to Azure, you really still have that bottleneck in the database. There's some tools you can use like sharding, but we really have that bottleneck as we move. But in addition to that, we really wanted to move away from having to manage the infrastructure and move away from infrastructure as a service to platform as a service, where we kind of let Microsoft manage that for us. Finally, we really want to leverage this as a paradigm shift within the industry. It only comes around every 10 years or so, as you know. And because we weren't meeting the business agility needs, it seemed like the right time to re-architecture, not just because devs like to rewrite things, but because we really needed to do that to meet the future needs.
So you just mentioned platform as a service. And for the benefit of our audience, can you tell us a little bit about what in Azure, what are some of those capabilities in Azure, or some of the platform as a service capabilities in Azure, made MSIT decide to go in that direction versus virtualization or perhaps a different type of solution?
Well, we're really using the gamut of Azure technologies, platform as a service capabilities. We're using web role and worker role. I think those are the main ones that people are familiar with. But we're also using Azure Queues. We're using Azure Table Storage. We're using SQL Azure, of course. But we're also using access control services and Service Bus. And each of those fills a vital role in fulfilling our architecture.
So you just mentioned a plethora of technologies that are part of the capabilities of Windows Azure, worker roles and web roles and so on. Do you mind walking us through the architecture and telling us a little bit about how each one of those components are really used within the context of the architecture for the platform velocity platform, partner velocity platform, sorry.
Sure. So really, we have this on-premise database, like you said before, and right now our organizations come into that database, our individuals, our assets, and we didn't really have time to redo all those integration points, so we left that as is, and so those come into our on-premise database, and we use different things like SSIS jobs to get that data over to the cloud, and even though it's mastered on-premise, we make a copy in the cloud. We also use a Windows service to move our assets, and that goes through an OData web service in the cloud, and that OData web service puts that data in Azure Table Storage. In addition to that, it'll write to an Azure Queue to trigger an asynchronous worker role to be able to go ahead and evaluate whether those assets cause some sort of requirement to be flipped for that partner. That evaluation is done via like I said, scale out worker role, multiple instances, and we can scale out to whatever the current load is on the system. When that is done, it stores that result in SQL Azure, so because that is the data that we have to query often and we need ready access to. And then because all our existing systems are tied still to on-premise and we have a hybrid architecture, we use SSIS to move that back to on-premise. So that's kind of where we are today. We're going to keep moving forward and adding more and more of those capabilities in the cloud. Now that we have that foundation, we're really done with the data movement, and the architecture can just evolve from there.
So you mentioned a whole bunch of technologies, but I want to focus on the Azure Table Storage component that you mentioned. Obviously, we have SQL both on-premise, from what I heard. We have SQL Azure as well that we use on the cloud. But then you mentioned this Azure Table Storage. But why not use SQL in the same way that you use it on-premise? Why go to this additional storage component?
That's a good question, and a lot of people ask that. The main reason is the right tool for the right job. So SQL is great. We use SQL in this solution. But when you have data that is not really relational in nature, when you have data, for example, our assets are really property bags of data. And when you have data that is easily partitionable, so our partition is a partner, then Azure Table Storage really can be a good solution for this because it is designed to load data either by partition or by key. It can load that data fast, and it is designed to be massively scalable on the order of 500 requests per second per partition. So when you think about the fact that a partner is a partition, we have 640,000 partitions of our data, and it becomes really massively scalable. So that it's the right thing. And then when you look at also the price per gigabyte versus SQL Azure versus Azure Table Storage, our assets have a lot of data in them, not really relational. Azure Table Storage ends up being a cheaper storage solution. We also look at the right tool for the job in other contexts. So for example, we're using worker roles to do our computation instead of the database. Historically in the on-premise system, we did that in the database. We were closer to the data and we got good performance, but we did not get good scalability. So as the system needed more and more load, that one database box just could not handle that load. And so we moved that out to our worker roles in order to really scale out.
Well, as someone who likes to tinker and as a self-taught handyman, if you will, I can definitely understand having the right tool for the right job, because I definitely have botched a lot of projects of my own by not having the right tool. But in the process of doing so, it looks to me that you may have created a lot more complexity for the organization in the meantime, because now you have a system running on-premise, you have a system running on the cloud, and a lot of moving parts. So can you talk a little bit about some of those complexities and some of the things that you may have been forced to do in order to mitigate some of those complexities?
That's very true. There are more moving parts in our new architecture. We have data sync between the cloud and on-premises. Data integration is hard, especially with something like the cloud that is not as reliable as a server that's sitting right next door in your own data center. So we had to do things like error handling, change detection, make sure that it's asynchronous. We had to manage throughput versus latency, and you have more latency when you're moving to the cloud and you don't control it. And then SSIS, for our team was pretty new. So that's a new complexity, but once we move that to the scale that we get, the agility that we get, has been well worth the cost. Another piece of complexity that we have is just the operation paradigm, right? So we needed to design for operations. You have operations that span multiple systems in multiple data centers. How do you know that it's working end to end? We had to make sure that we bake that in from the start. And then also our operations is moving more from a reactive monitoring, something went wrong, to more proactive, because a lot of the stuff is just off their plate by moving from infrastructure to a service. They're not managing patches, they're not managing the network tier, so they just have time to be just more proactive and deal with things. Deployment and configuration management, as you can imagine, is also a lot more complicated, because you have these different endpoints and things like that. And we've even had issues where we had our testing environment accidentally point to our production environment, and we had to fix that. So those are things you have to watch out for. But all in all, if you think through these problems, they're solvable.
Yeah. So I think we finally got that problem of UAT environment, pointing to production environment under control. But yeah, those are excellent lessons to learn and things to keep in mind as anybody tries to move an on-premise application to the cloud, or in the case as PVP, have a hybrid solution. So now, looking over the last few minutes of conversation, we have talked about platform as a service and how Azure provides some of those capabilities. We talked about software as a service, perhaps not as much as time would allow us, but at least within the context of how we could potentially provide new software as a service capabilities to the enterprise by re-architecting this. And then we talked about some specific technologies within Windows Azure, like Azure Table Storage, SQL Azure, Queues, and so on. Before we wrap up, can you tell us a little bit about some of the benefits that overall you see of taking this monumental task of moving such a large application like PVP from an on-premise solution to, at least for the moment, a hybrid solution, and eventually all the way to Windows Azure?
So as you can imagine, it is a big application, and moving it all at once was just not feasible. But by moving these parts, and the more compute-intensive parts, the parts where we were inhibited by scale, we have managed to achieve elastic scale. And so it's not just scale up, because one of the things we haven't covered is we live in a very seasonal business and partner. In the spring is when most of our re-enrollments come. So we want to scale up to meet that demand, but the rest of the year, we want to be able to scale back, because we just don't need to use those resources, and that's something we can do.
So cost is a benefit.
Well, and the projected cost savings was huge. We did a double and triple take, as you remember, because we looked at the numbers for Azure, and they just seemed too low. And so,
well, if I recall, we actually tripled our estimates just to make sure that we were safe. And as it turns out, we're still well under that triple. Yeah. So that's
but you still have the bump that you're maintaining an on-premise, but as that goes all the way to the cloud, that bump will go away. But finally, we talked about software as a service a little bit, but the software as a service, we're building capabilities in the cloud that not just the partner system can use, that other systems can use, and really enabling a software as a service. And that's driven through a new architecture, driven through event-driven architecture, pub-sub mechanisms in the cloud. And that just really would have been a lot more difficult to do on-premise, and it's one of the reasons we didn't do it until now, even though we had scale issues. And so one of the things like I like to point out is if you had to do an asynchronous architecture on premise, you would be doing MSMQ, things like that. And those are just really difficult, but the same thing in the cloud, queues, service bus are much, much easier.
Yeah, and something that you just mentioned in terms of the software as a service, today we predominantly serve our WPG business, internal business, but if you can, as you can imagine, we actually have a whole bunch of other organizations within Microsoft that could potentially reuse these services if we architect them in the right way. So this is fantastic. Well, Cleve, thank you so much for sharing with us today. This has been very, very useful. Unfortunately, we are out of time for today, but perhaps you can come back and tell us a little bit about how the entire project finished sometime in the future. I also want to thank our audience for joining us today. We hope this information has been useful. If you would like to learn more about what work MSIT is doing as we move PvP and other applications to Windows Azure, please contact your sales representative or visit us on the web at the IT Showcase website. Thank you, everyone, and see you next time.